Mary, it's so sunny. Can I have my sunglasses?
Yeah.
What did you do to lenses?
I popped them out.
Why?
In the name of science.
Waves vibrate in all directions perpendicular to the direction in which they travel. When the transverse wave enters a polarizer, the polarizer blocks all vibrating components but one, decreasing the light intensity once it exits the polarizer. This wave is now linearly polarized. One common application of polarization is the use of polarized sunglasses. The lenses of the glasses consist of tiny polarizing crystals, which make light look dimmer to the observer, which is why they're very useful when it's a sunny day out and you're trying to drive. Polarizing lenses also prove that light waves are transverse because longitudinal waves cannot be polarized. Now, if one polarizing lens is cool, you can imagine that two are even cooler. So, as you can see here, that as you change the angle between the two lenses, the final light intensity also changes. So now you're probably wondering, what's the relationship between them? Well, let's find out. The equation used to describe the intensity of light traveling through two polarizers is the final intensity is equal to the initial intensity over 2 times cosine squared theta. The first part of the equation refers to the effects of one polarizer, meaning when the light passes through one polarizing filter, its intensity decreases by half. We found that the average intensity of solar energy reaching the top of the atmosphere is 1,360 watts per meter squared. So that is what we use as the initial intensity for our calculations. So when a second filter is introduced, the angle between the two polarizers determines the final intensity. As you can see, as the angle between the two polarizers increases, the final light intensity decreases. So half the initial intensity passes through two filters when they are parallel, and all the light is blocked when they are perpendicular. So if the two polarizers are parallel to each other, then it would be the same as if it was only one polarizer. And if they are perpendicular, then no light passes through. We measured the final light intensities when the filters were oriented 0, 30, 45, 60, and 90 degrees from each other. It makes sense that when they were parallel, the final intensity is exactly half the initial intensity because that means the second filter had no effect. And then as you can see, when we oriented them 30 degrees from each other, the intensity decreased to 510 watts per meter squared, and then it continued to decrease to 340, 170, and eventually 0 when they were exactly parallel to each other. So yeah. So this is a little demonstration of what we just quantified. These are two polarizers, and right now they're parallel to each other, as you can see with the little piece of tape, is at 0 degrees. So as we orient them 30, the space where they cross is darker, and that's because the light intensity decreases. So that would be about 510 watts per meter squared at 30. Then the 45, it gets darker. That's about 340 watts per meter squared. 60 is 170. And you can see it keeps getting darker as we increase the angle. And then when it's parallel, no light comes through.
Sources of error in our experiment would be that we did not have the ability to measure the actual intensity of the light. Also, different scratches, smudges, or dust on the lenses would affect the angle of the light rays through the lens, and as a result, affecting the final intensity of the light. These are the bloopers! We good?
Okay, we're ready.
We're ready? Sorry.
I just dropped the glass.
So difficult! Let's whip around the school.
Oh, it's really sunny. Can you pass me my sunglasses?
And I'll say, here you go. You just like, wait, start over.
You start with what a beautiful day for physics.
Find them.
Lena, why's your car a mess? It is not a mess.
I lost the glasses.
Yeah, I know, it's like a black hole down there.
These days are tough, these days are long.
They're trying to stop you. Run, boy, run. This race is a prophecy. Run, boy, run.
Stop shaking it.
It's physics.
Lena, stop shaking the camera.
It's physics.
Stop. Good thing we have that tape.
There's a galaxy, but it's far in the distance. I'm asking you to show me some forgiveness. It's offering in my pursuit of happiness. Singing, oh, happiness. Singing, oh.
Now you need to hire more people.
Oh, the searching, the email. Where do we start?
ZipRecruiter. Whether you're looking to fill one position or 20, ZipRecruiter makes hiring simple. One click.
I'm asking you to show me some forgiveness.
They're looking at us weird.
It's offering in my
What?
Look at that. That's crazy. And
They're
there's
like,
got a little excited there.
yeah.
Oh, I popped them out. I'll say why, and I'm like, in the name of science. But the lenses are gone. That's kind of the important part.
How do you lose? They were in the
They
car.
were in my lap. And your reckless driving made them slide off because of inertia.
Venus. I got dreams that keep me up in the dead of night. Telling me I wasn't made for the simple life.
Okay, I'm going now.
Oh, I found one! One down.
Unfortunately, this lab only works with two, so we need.
Because I circled the school like 20 times.